Good day, student. This is STA 201. I will be taking you through study section 6, Estimation and Hypothesis Testing. Researchers are interested in answering many types of questions. For example, a scientist might want to know whether the earth is warming up. A physician might want to know whether a new medication will lower a person's blood pressure. An educator might wish to see whether a new teaching technique is better than a traditional one. These types of questions can be addressed through statistical estimation and hypothesis testing, which is a decision-making process for evaluating claims about a population. In this study section, we will learn how to use simple data to estimate unknown population parameters. On the completion of this study section, you should be able to define estimation, you should be able to understand and explain point estimate, and lastly, you should be able to estimate confidence interval. Estimation is the entire process of using an estimator to produce an estimate of a parameter. Estimation and hypothesis testing are interrelated. Estimation and hypothesis testing are interrelated. An estimate is any specific value of a statistic, while an estimator is any statistic used to estimate a parameter. A point estimate consists of a single number calculated from the data that is best single guess for the unknown parameter. An interval estimate consists of a range of numbers around the point estimate, within which the parameter is believed to fall. For example, the sample mean is used to estimate the population mean. A point estimate is obtained when a single number is used to estimate a population parameter. For example, if x is equal to 30, an interval estimate is obtained when a range of value is used to estimate a population parameter. Let's move on as we talk about point estimation. The object of point estimation is to calculate from the sample data a single number that is likely to be close to the unknown value of the population parameter. The available information is assumed to be in the form of a random sample like x1, x2 up to xn of size n taken from population. The object is to formulate a statistic such that its value computed from the sample data will reflect the value of the population parameter as closely as possible. A point estimator of an unknown population parameter is a statistic that estimates the value of that parameter. A point estimate of a parameter is the value of a statistic that is used to estimate a parameter. For example, to estimate population mean, perhaps the most intuitive point estimator is the sample mean, which can be calculated as x is equal to x1 plus x2 up to xn divided by n. Once the observed value, that is x1, x2 up to xn of the random variable are available, we can actually calculate the observed value of the sample mean, which is called the point estimate. A good point estimator of a parameter is one which sampling distribution that is centered around the parameter and as small standard error as possible. A point estimator is called unbiased if its sample distribution centers around the parameter in the sense that the parameter is the mean of the distribution. For example, the mean of the sampling distribution of the sample mean equals point estimate. Thus, the sample mean is an unbiased estimator of the population mean. A second preferable property of an estimator is a small standard error. An estimator whose standard error is smaller than those of other potential estimators is said to be efficient. An efficient estimator is desirable because on the average it falls closer than other estimators of the parameter. For example, it can be shown that under normal distribution the sample mean is an efficient estimator and hence the smaller standard error compared. For example, in a sample medium. Let's talk about the point estimators of the population mean and standard deviation. The sample mean is the obvious point estimator of a population mean. In fact, sample mean is unbiased and it is relatively efficient for most population distributions. It is the point estimator and is denoted by mu, which is equal to x, which is equal to x1 plus x2 up to xn over n. So you can master what point estimator is and what are the conditions, various conditions surrounding point estimation. Let's move on as we talk about confidence interval. For point estimation, a single number lies in the forefront even though a standard error is attached. Instead, it is often more desirable to produce an interval of values that is likely to contain the true value of the unknown parameter. A confidence interval estimate of a parameter consists of an interval numbers obtained from point estimate of the parameter together with a percentage that specifies how confident we are that the parameter lies in the interval. The confidence percentage is called the confidence level. The confidence interval for a parameter is the range of numbers within which the parameter is believed to fall. The probability that the confidence interval contains the parameter is called confidence coefficient. This is a chosen number close to 1 or such as 0.95 or 0.99. I hope you have learned one or two things in this video tutorial, and I hope you will continue to learn more. Thank you for listening.